Now in the last video, we have looked at how we can apply the 3C approach to solving chemical calculation questions. In this particular video, we are going to look at a specific type of chemical calculation questions known as limiting excess questions. Before we even go into that, we need to clarify three terms. The three new terms are limiting, excess, and stoichiometric ratio. So let us start by looking at a random mathematics problem again. So we have a pastry chef who has 3 puddings and 6 raspberries. So based on the picture of the dessert, can you all determine how many bowls of dessert can the pastry chef make? I'm sure all of you all will be able to tell me that he's able to make 3 bowls of dessert. Now in a second scenario, now the pastry chef has 3 puddings and 10 raspberries. So once again, how many bowls of dessert can he make? I'm sure again, many of y'all will be able to tell me that it is 3 bowls, okay? But at this point in time, I would say, why 3 bowls? Because now we have more raspberries, so shouldn't we be able to make more bowls of dessert? And the answer, of course, is that we don't have enough puddings to make more dessert, okay? So in the third scenario, we have 5 puddings and 6 raspberries. So earlier we didn't have enough puddings, so now we have more puddings. So how many bowls of dessert can we make? Again, it is 3 bowls. Despite having more puddings, now we don't have enough raspberries to make more than 3 bowls of dessert. So in the 3 scenarios, what did we encounter is this, that in the second scenario, okay, let's call it A, B, and C. In scenario B, despite having more raspberries, we can still only make 3 bowls of dessert. Okay, why? Because we are limited by the puddings. We don't have enough puddings. So in this case, the pudding is known to be limiting, or the limiting reactant. The raspberries, we have more than enough. So after making the dessert, we will have some raspberries remaining. So we say that the raspberries is in excess. Similarly, for scenario C, even though we have more puddings now, we are limited by the number of raspberries. So the raspberries in scenario C is limiting. And now after making the dessert, we will have some puddings remaining. So your puddings would be your excess reactant. Okay, so in scenario A, I hope you all can see that when we have 3 puddings and 6 raspberries, when we make the dessert, there will not be any of your pudding or raspberries remaining. Okay, in a reaction sense, we say that the reactants have been added in what we call stoichiometric ratio. Okay, meaning they have been added in just nice amounts according to the reacting ratios, such that there is no leftover of any of the reactant. So we have encountered 3 new terms. As mentioned in scenario A, when the reactants are added according to the reacting ratio or the mole ratio, it is in stoichiometric ratio. When there's too much of one reactant, we say that it is in excess. When there's too little of one reactant, we say that it is limiting. Okay, so before we even go on, you need to understand the 3 new terms. What is meant by stoichiometric ratio, what is meant by in excess, and what is meant by limiting. Now when you look at the problem, many of y'all would think of this, why can't we change the number of raspberries on the dessert so that we can make more bowls of dessert? Now in a real life scenario, yes, that is possible, but in a chemical reaction sense, if you can recall, the reacting ratio, the ratio between the 2 reactants is determined by the coefficient in the chemical equation. Okay, for example, when sodium reacts with chlorine, you will always have this particular ratio. 2 moles of sodium must react with 1 mole of chlorine. Now what happens if we change it to Can we anyhow change this to 3? The answer is no, because then the equation will no longer be balanced. Okay, so in a chemical reaction, the reacting ratio, the ratio between the two reactants is fixed by the balanced chemical equation. Now let us look at an actual limiting excess question. And before we even go into solving the question, I want you to be able to spot a limiting excess question when you see one. A trademark or feature of a limiting excess question is this, that the amount of both reactants are given in the question. So if you look at this question, you are given 2.3 grams of sodium reacting with 0.5 moles of acid. So in questions where you see that the amount of both reactants are given, this tells you that the question is a limiting excess type question. Okay? So to solve limiting excess type questions, there is also a fixed approach, and we are going to go through the fixed approach now. Step 1, we have to find number of moles of both reactants. So in this case, we have to find number of moles of sodium, and we are given the mass of sodium. So by now, I hope you are already very familiar that given mass, we have to divide by molar mass to find number of moles of a particular substance. Okay, once again, when you find the molar mass of a substance, we do not consider the coefficient, meaning the big number in front of the substance. For number of moles of hydrochloric acid is already given in the question, so there's no need for us to find. So we have completed step 1, which is to find number of moles of both reactants. Now step 2 is this, we have to pick any one reactant. Okay, we have to pick any one reactant. Okay, and after that, using the mole ratio as given in the chemical equation, you need to find the number of moles of the other reactant needed. Okay, so what do I mean by that? So in this case, we have two reactants. We have sodium and we have hydrochloric acid. You can pick any one reactant. Okay, you will always arrive at the same conclusion. So for example, if I were to pick sodium, we have found that number of moles of sodium is 0.1 mole. Okay, so I'm going to make use of the mole ratio indicated in the chemical equation to find out the number of moles of hydrochloric acid needed to completely react away my sodium. Okay, so from the chemical equation, we can see that the ratio between sodium and hydrochloric acid, or the ratio between the two reactants, is 2:2 or 1:1. That means that if I have 0.1 mole of sodium, I will need 0.1 mole of hydrochloric acid to completely react with the sodium present. Okay, the next step is this. Then you need to compare the number of moles of acid needed with the number of moles of acid that is present, which you have found in step 1. In step 1, we have found that number of moles of acid present is 0.5 moles, and this is more than the number of moles of acid needed. Okay, so the number of moles of acid present is more than the number of moles of acid needed. So what does that mean? It means that your HCl, or your hydrochloric acid, is in excess, and that your sodium is the limiting reactant. Now you may be wondering what happens if I had picked hydrochloric acid and used the mole ratio to find the number of moles of sodium needed. You will arrive at the exact same conclusion. So it doesn't matter which reactant you pick, if you follow the correct steps, you will arrive at the same conclusion. Okay, so we have found that the limiting reactant here is sodium, and for part B, you are supposed to calculate the number of moles of the reactant that remain, that is left over. So it is the excess reactant that is left over. So from again step 2, we can see that the number of moles of hydrochloric acid present is 0.5 mole. The number of moles of acid needed to react with the sodium is only 0.1 mole. So that means that we would have 0.4 moles of acid that is remaining. Now once again, this is the approach for solving excess limiting type questions. Step number 1, you need to find the number of moles of both reactants. Step number 2, you need to pick one reactant and using the mole ratio as shown in the chemical calculation to find the number of moles of the other reactant needed. Once you have found the number of moles of the other reactant that's needed, you need to compare with the number of moles of the other reactant that's present. If the number of moles needed is more than the number of moles present, then that reactant is limiting. If the number of moles needed is less than the number of moles present, then the reactant is in excess. Now we're going to learn another very important concept that's related to the limiting excess type question. And for that, let us go back to the 3 scenarios again. We have scenarios A, B, and C. Now based on the 3 different scenarios, I need you all to derive this conclusion that in the 3 scenarios, the number of bowls of dessert depends on the number of what? Is it the number of puddings? Is it the number of raspberries? Now, from this, I hope you can tell that it is not always the puddings, it's not always the raspberries, but it depends on whatever that is limiting. Okay, so the number of bowls of dessert depends on the number of limiting. In this case, the reactant means either the pudding or your raspberries. Now, this is a very important concept to remember because in a chemical reaction, the amount of product that is formed, if you are asked to find the amount of product, it depends on the amount of the limiting reactant. So we're going to apply that to the same question that we saw earlier. We have done part A and B already. Now let's look at part C. They want you to calculate the mass of sodium chloride formed. Okay? Sodium chloride is the product in this reaction. Okay? So how do we find the mass of sodium chloride formed? Again, we go back to the 3C approach. Okay? Step 1, convert to moles. Now, what do we want to convert to moles? We have 2 reactants here. Remember, the amount of product depends on the amount of limiting reactant. And we have seen in earlier that the limiting reactant is sodium. And we have also calculated that the number of moles of sodium is 0.1 moles. So step number 1, first C is to convert to moles. Second C is to compare mole ratio. Compare mole ratio between what? Between your limiting reactant and the product that is formed. So when you look at the balance equation, the ratio again is 2:2 or 1:1. So that means that the number of moles of sodium chloride formed would also be 0.1 mole. And lastly, we need to find the mass of sodium chloride. And we have learned earlier that when we are given number of moles, we can multiply that by the molar mass to find number of moles. So in this case, it would be 5.85 grams. So what we have learned up to this point is this, that when we are given a limiting excess type question, we can follow a certain approach to find out which reactant is limiting and which one is in excess. And then when we are supposed to calculate the amount of product that is formed, we look at the limiting reactant, we look at the number of moles of limiting reactant, and then we compare the mole ratio between the product and the limiting reactant. So let us now apply the approach again to a second example. So in this particular question, once again, I hope you can recognize that it's a limiting excess type question before even reading part A and B. Why is that so? Is because you are given the mass of two reactants. You are given the mass of carbon tetrachloride and you are given the mass of antimony trifluoride. So once again, if you are given the amount of both reactants in the question, it's a limiting excess type question. Okay, and step number 1 of a limiting excess type question is to convert or find number of moles of both reactants. Okay, so we need to find number of moles of CCl4 and number of moles of SbF3. Sb is antimony, it is a group 5 element. So over here, the mass of CCl4 is 150. The molar mass of CCl4 is actually 154. Okay, you can do a calculation that will give us 0.974 moles. And then the number of moles of antimony would be the mass divided by the molar mass. The molar mass of antimony is 122 plus 3 times 19, and that would give us 0.559 mole. Okay, so step number 1 in a limiting excess question once again is to find the number of moles of both reactants. Next, we have to pick one reactant. So in this case, for example, if I were to pick my antimony trifluoride, okay, we have found that there is 0.559 mole. So step number 2 is to use mole ratio between the two reactants to find the number of moles of CCl4 that is needed. So from the reacting ratio in the balanced chemical equation, we can see that 3 moles of CCl4 reacts with 2 moles of antimony trifluoride. So the number of moles of CCl4 needed would be 3 over 2 times 0.559, and that would give us 0.838 moles. Okay, the last thing is to compare the number of moles of CCl4 needed versus the number of moles of CCl4 present, which is found in step number 1, which is 0.974 moles. So over here we can see that the number of moles of CCl4 present is more than the number of moles of CCl4 needed. So what does that mean? It means that CCl4 is in excess and your antimony trifluoride SbF3 is limiting. So up to this point, we have yet to solve any part of the question, but we have determined that your antimony trifluoride is the limiting reactant and your CCl4 is the excess reactant. So in part A, you're supposed to find the mass of the product, which is your Freon 12 or your CCl2F2. Okay, once again, when we need to find the amount of product, we need to look at the limiting reactant. So in this part, we're going to focus on your antimony trifluoride. Now earlier, we have already found that the number of moles of antimony trifluoride present is 0.559 moles. Okay, so step number 1 of the 3C is to convert to moles. Step number 2 is to compare mole ratio to find number of moles of your product. So number of moles of CCl2F2 by comparing the mole ratio given in the chemical equation would be equals to 3 over 2 times the number of moles of your SbF3, and that would be equal to 0.838 moles again. And third C is to convert from moles. So now that we have found number of moles of CCl2F2, we can find number of moles by taking the number, we can find mass by taking the number of moles times the molar mass, which is 12 plus 35.5 times 2 plus 19 times 2. And that would give us a value of 121 and a final answer of 101 grams. Okay, so once we know the limiting reactant, we can use the 3C approach to find the mass or the amount of a product present. For part B, we are supposed to find the mass of unreacted excess reagent or reactant. So the excess reactant is carbon tetrachloride. We have found that the number of moles of CCl4 present is 0.974 moles. And then we have also found that the number of moles of CCl4 needed is 0.838. Okay, so the number of moles of CCl4 in excess would be the difference, and that would be 0.136 moles. So after the reaction, you will have 0.136 moles of CCl4 remaining. And again, the question doesn't want number of moles, they want the mass. So you can easily find the mass by taking number of moles multiplied by the molar mass. The molar mass of CCl4 again is 154. So that will be equal to 20.9 grams. So once again in this lesson, we are looking at a specific type of chemical calculation questions, which is the excess limiting type of question. In the excess limiting type of question, we must first convert or find number of moles of both reactants, and we need to pick one reactant and using mole ratio of the both reactants to find the number of moles of the other reactant needed. By comparing the number of moles of the other reactant needed with the number of moles present, we can then determine whether that reactant is in excess or limiting. Following that, we can find the amount of product by comparing the mole ratio of the product with that of the limiting reactant. So lastly, the amount of product formed depends on the amount of limiting reactant present.